Okay, today we're going to start looking at Chapter 8, confidence intervals, just some basics of confidence intervals. When I return, we will start looking at certain exact intervals for proportions and means. So this is just going to be kind of a quick introduction. So when we look at our confidence intervals, just some definitions that we will need to know. We've kind of talked about some of them before. So a point estimator is a statistic that provides estimate of a population parameter, just like we were kind of been estimating what we were doing with our probabilities and stuff. So a point estimator, they're going to be like of our proportions or of our means. Those are going to be our two most important ones that we are going to do. You could do standard deviation in all of them also. The value of that statistic from a sample is called the point estimate. So like p hat, x bar, whatever information we're getting from our sample. Ideally, a point estimate could be our best guess at the value of an unknown parameter. Like we don't know what it is, but this is what we think it is. So kind of a best guess of what we're looking at. The point estimator can be a mean, proportion, standard deviation, like I said, median. We are going to deal mainly with means and proportions in this class. So if we look at point estimators and we want to identify one, so here we want to identify the point estimator you would use to estimate the parameter in each of our following settings, and we're going to calculate it. So here we're talking about quality control inspectors estimating the mean lifetime of AA batteries produced each hour at a factory. So they select a random sample of 50 batteries each hour of production and then drain them under conditions that mimic normal use. And here is the lifetime of those batteries, and it gives us all our information. So when we want to do our point estimator, well, what are we looking at? We want to estimate. What is it we're estimating? We want to estimate the mean. So the mean is what we're looking at estimating, which is going to be the sample mean. So X bar is a point estimator for our population mean. We don't know our population, so we're going to have to use from our samples. The point estimate, you actually have to find X bar, which means of all this data up here, you need to find the mean. Okay, well, you could add all those up and divide by 50, which is something that we could do. Also remember that you can put all that information into your calculator, all that data into your calculator, and do your 1var stats and find the mean also. So either way, just making sure that you remember how to do that. We did that first semester, something you'll need to remember. Second situation, we have what proportion P of US adults would classify themselves as vegan or vegetarian. So there was a report surveyed 1,473 randomly selected US adults. Of them, 124 said they were vegan or vegetarian. So what is going to be our point estimator? Well, we want to estimate the proportion. We're estimating P, so what we use to estimate P is going to be P hat. We don't know P, we use P hat. In this case then, to find P hat, 124 out of 1473. So we're just going to divide it. 124 divided by 1473.084. Then here's our last one of these. We have the quality control inspector. In part A, want to investigate the variability in battery lifetimes by estimating the population standard deviation. So what do we use to estimate our standard deviation? Our population is theta. We estimate it with our S of x. Okay, so you could go through. I would not recommend finding S of x by hand. You get it in your calculator. If you put in all that data, it's under your 1var stats again, and you should be able to get that. I would highly recommend, if you did not, plug that data in and make sure that you know how to get those two estimates. Okay, so when we have an estimate of a parameter, we're going to report it as an interval of values of some kind. That interval of values is called our confidence interval. Okay, so a confidence interval gives an interval of plausible values for a parameter based on sample data. Normally our confidence intervals are going to be written in parentheses where it's going to go from something to something is what it's going to look like. Okay, as a little side note here, plausible does not mean the same thing as possible. Plausible means that we shouldn't be surprised if one of the values in the interval is equal to the value of the parameter. We're not saying it's only the possible ones, it's just plausible ones that we think make sense. Okay, confidence intervals are constructed so that we know how much confidence we have in the interval. So the most common confidence interval is a 95% confidence interval. You'll see that a lot. But it could be a 98% confidence interval. It could be a 90% confidence. It could be an 80. There's all sorts of different percents that we could use. So the confidence level, we're going to let that be capital C, gives the overall success rate of the method used to calculate our confidence interval. That is, C% of all possible samples, the interval computed from the sample data will capture the true parameter value. So one of the things that we're going to get into is interpreting confidence intervals and interpreting confidence levels. So you'll need to know the definition to be able to interpret them. We'll do some examples. So our most common, again, is 95%, which means we are 95% confident in our success rate. If we were to take a bunch of samples, there could be a different one. It just depends on what interval they ask us to do. Okay, to create an interval of plausible values for our parameter, we need two components, a point estimate, which we just looked at on how to find, and that is going to be the midpoint of our interval. So that's always going to be the middle. And we need what is called a margin of error, which is going to account for our sampling variability. So the general formula for a confidence interval is we take that point estimate and we add or subtract our margin of error. And that gives us what we're looking at. So if you think about it, our point estimate could be right here in the middle, and then we were going to subtract to get an endpoint of our interval, and then we will add to get an upper value, an endpoint of our interval. Okay, so the margin of error of an estimate describes how far at most we expect the estimate to vary from our true population value. So that is, if we think about it, if we have a certain percent confidence interval, the distance between the point estimate and the true parameter will be less than the margin of error in whatever our percent is of all those samples. Again, we'll start looking at our interpretations also, which is what we're going to do next. So for interpreting a confidence interval, this is kind of a general format. You can write it every single time. You'll kind of see me write it some different ways also. But to interpret a confidence interval, so a certain confidence interval for an unknown parameter, you would say something like this. We are C%, if you were 95, 90, whatever you're using, confident that the interval from, and this would be what we calculate, captures the, and this is going to be in terms of the problem. Okay, so you could always start the exact same way, which is what you will usually see me do. Okay, note some people include the phrase based on the sample data when interpreting a confidence interval. You can or not, it doesn't matter. But on AP exam tip, when interpreting a confidence interval, make sure that you are describing the parameter, not the statistics. You're describing the parameter that's in the problem. So if we look at an example here, we have 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or B? Based on the poll, we made a 95% confidence interval for the population proportion who favor candidate A. And here is our interval. Notice it's written with our parentheses. That's how we're always going to write our intervals. So A, we want to interpret the interval. So interpreting it, we start just like that sentence I just gave you in your notes. We are 95% confident that the interval from 0.48 to 0.54, captures the, and then you have to look at what we're looking at, the true, notice the word true proportion of all registered voters who favor candidate A in the election. I will be very picky on your interpretation, so make sure you are writing them out. Today you won't have to write them out, they're multiple choice, but you will be writing them out eventually. Part B wants the point estimate that we use to create the interval and the margin of error. Well, if my interval is 0.48 to 0.54, remember the point estimate is always in the middle of that. So what value is in the middle of 0.48 and 0.54? If you're not sure to find it, what you can do is add the two numbers together and divide by 2, so our point estimate is 0.51. So then the margin of error is, well, what did I need to do? 0.51 plus what gave me the 0.54? Whatever this value is our margin of error. So our margin of error, 0.54 minus 0.51, 0.03, another way that you can look at it, separate from what I wrote up there. Okay, you can also find the margin of error by finding the half width of the interval. So you could subtract the interval and divide by 2 is another way to find it. Either way is fine. And then part C, based on this poll, a political reporter claims that the majority of registered voters favor candidate A. We want to decide if that is true, or we want to evaluate that claim using this interval and the fact that they claim that they favor candidate A. Well, to favor candidate A, you would have to be 50% or higher, right? Because there are plausible values of p less than or equal to 0.5 in the confidence interval, the interval does not give us convincing evidence that a majority of more than 50% vote. Because I have some numbers in here that are less than 50%, then I would say that the claim is not very good. Okay? So it doesn't give us convincing evidence that a majority actually do. If it was 0.5 and higher, then yes, we could say that it does. Okay? That was interpreting the confidence interval. Now we're going to interpret the confidence level. They're not the same thing. You have to know the difference. To interpret a confidence level, we say if we were to select many random samples from a population and construct a whatever our percent is confidence interval using each sample, about C% of the intervals would capture the whatever it is, the parameter in the context. Okay, so when we are looking at this, if we think about an example, same one with our presidential election, we are 95% confident. So what does this 95% confidence mean? What does that confidence level understand if we're interpreting it? So if I'm interpreting that level, you could say something like this. If we were to select many random samples of the same size from the population of registered voters and construct 95% confidence interval using each sample, about 95% of the intervals would capture the true proportion of all registered voters who favor candidate A in the election. So that's saying if we did 100 different samples and we created 100 different confidence intervals, this is saying that we would expect 95% of those 95 of those intervals out of 100 to capture the true proportion. There's some error right there because I'm not 100% confident. So if you think about it, looking at it, if you were making a bunch of different confidence intervals, okay, with our true proportion mu right here, you can see, oh, it's in here. Oh, well, this red one didn't capture it. Okay, so it's because of that error, there are possibilities that sometimes they will not capture it. So 95%, for example, if you had 100 confidence intervals, you would expect 95 of them to capture the true population proportion or mean, whatever it is that you're looking at. And then some of them would not. Okay, the confidence level, as a little caution here, does not tell us the probability that a particular confidence interval captures the population parameter. It's how many in a bunch of samples we would expect to. AP exam tip, again, on a given problem, you may be asked to interpret the or both. So make sure you understand the difference. Okay, I guarantee you will have tests. You'll have to interpret both of them at some point or another. Okay, so then looking at our margin of error, well, if we're more confident or less confident, that changes that margin of error. So in general, we prefer an estimate with a small margin of error because we want to be, give as small values as possible. So the margin of error gets smaller when the confidence level decreases. So if I'm less confident, for example, down here, if I'm 80% confident as opposed to 95% confident, my confidence interval gets smaller. That makes my margin of error smaller. Okay. If the sample size increases, then that also makes our margin of error smaller because we're going to be dividing by an n. So in general down here, the width of a confidence interval for a proportion or mean is proportional to 1 over the square root of n. So that means if I quadruple the sample size, that cuts my margin of error in half. I would know this. You're going to have problems, questions, multiple choice questions that will ask you some different things like that. Okay? So a note of caution, the margin of error does not account for any kind of bias in our data collection process. If we have bad data collection, we just have bad data collection, okay? So what affects the margin of error? For a normal sampling distribution, extending about 2 standard deviations in each direction will give us approximately a 95% confidence interval, okay? So for a normal sampling distribution that is 3 standard deviations, it's about a 99.7% confidence interval. The more general formula for our confidence interval is the statistics plus or minus a critical value times our standard deviation. And we'll get into exact formulas for each one as we go, but this is the general formula that's on your formula sheet that you will see. Okay, so the critical value, what is it? It's a multiplier that makes the interval wide enough to have the stated capture rate. So depending on if we're 80, 85, 90, 95, whatever our percent is, that's going to change this critical value. Okay, so if we look at this as part of a project about response bias, a survey of random sample of 25 students from a school, one of the questions in the survey required students to state their GPA aloud. Based on the responses, She was 90% confident that the interval from 0.40 to 0.72 captured the proportion of all students at her school with GPAs greater than 3. So explain what would happen to the length of the interval if the confidence level was increased. So this was 90%. If I change it to 99%, if I'm more confident, that is going to make my interval larger. The confidence interval will be wider because we increase the confidence level, which increases the margin of error. More confident, bigger interval. Okay, part B, how would the width of a 90% confidence interval based on a sample size of 100 compare to the original 90% one? So here my sample size was 25. Here my sample size was 100, so I increased my sample size. The confidence interval would be half as wide because the sample size is 4 times as big. Remember that thing where I said I would know this and I circled it? Okay, that is what you need to know. So in this case, our confidence interval would be smaller because I made my sample size larger. And last, in that same situation, describe one potential source of bias in the study that is not accounted for by the margin of error, because remember, bias is not accounted for. So the margin of error doesn't account for the fact that many students might lie about their GPAs when having to respond. Okay, you're just saying it out loud. When you hear people say it, you might lie about what yours are. So the proportion of students with GPAs greater than 3 might be less than 0.4. Like if you randomly had to write it on a note and no one knew it was yours, you might not lie as much as having to say it out loud because you don't want people to say things about you. Okay, we are going to stop right there. You have an assignment on sapling over this. We will do this finding the critical value stuff next time. And that's what we'll pick up when I come back. Remember, we have tests on Tuesday, and then we'll pick up with this on Thursday. So if you have questions, make sure you're coming in to see me.